Hello. So on this video, we're still on chapter 5, section 1, I believe. Now we're going to be talking about types of angles. Right? So in the previous video, I gave you some common angles. So I gave you theta equals 45, theta equals 180, theta equals 270, theta equals 360, theta equals 90. And I didn't mention it, but of course, there's also the theta equals 0. Right? So actually, let me draw this here. So the theta equals 0, it's basically you don't move anything. Right, so theta equals 0 kind of just looks like a ray. So you really wouldn't draw this angle in most cases. You wouldn't draw anything. Again, the note here, usually you don't draw a 0-degree angle. And of course, all of these angles that I drew, you can make them negative, just move in the clockwise direction. So for example, let's say I want to do negative 270 degrees. So let me just do this here. If I want to do negative 270 degrees, well, I know what 270 degrees look like. Now I just want to move in the clockwise direction. So I want to move 90 degrees 3 times in the clockwise direction. So if I do that, initial side, I'm going to move now 90 degrees, but in the clockwise direction. So my terminal side is going to be here. And now this is my angle. Right, so very easy to do the negative variance of these angles. Just go the other direction. Okay. Now let's talk about types of angles. Again, this is something you should have seen in geometry or somewhere in high school, but the definitions are pretty easy. Right? So an angle is acute, and the book might do this differently. I'm just going to define acute as being between 0 and 90, including 0. So that means that our angle is between 0 and 90 degrees. That's what an acute angle looks like. And in terms of how this would look like in a picture, it's very simple. Just draw an angle that goes less than 90 degrees. So initial side is the positive x-axis, and then you want to go less distance than the whole up to the y-axis, so you can do something like this. This is less, I don't know what this is, but I know for sure this is less than 90 degrees. Now something that's obtuse, or an angle that's obtuse, is an angle that's between 90 and 180 degrees, not including these angles, right? So again, you can draw a very easy picture of this. So I want it to be less than 90 and in standard position, right? So everything I'm drawing here is in standard position, which is, again, what we're going to be doing all of the time unless stated otherwise. Right, so I draw my initial side on the positive x-axis. I want it to be bigger than 90, so I want to go past the vertical y-axis, but I don't want to go as far as to reach the negative x-axis. So we could do something like this. And then this angle here is, well, I don't know what it is, but for sure it's obtuse. It's between 90 and 180. A right angle, well, you know what it is. This is just because I explained it before. But this is basically an angle that's equal to, let me use the same color. It's an angle that's equal to 90 degrees. And then a straight angle is an angle that's equal to 180 degrees. Right, so those I already drew pictures in the previous videos, that's why I'm not drawing them anymore. Right? But just some things to remember. If someone says an angle is obtuse, for example, you know it's between 90 and 180. If it's straight, it's 180. If it's acute, it's between 0 and 90. Then right means that it's a 90-degree angle. Okay. Now, there are 2 more definitions that we have to go over, at least for now. They're pretty easy, though. So let me write them here. It's just definition 5. So two angles, alpha and beta, not necessarily in standard positions. But again, we will always be, most of the time, unless stated otherwise, we're thinking of angles in standard position. But two angles, alpha and beta, are complementary if their degree measurements or their angle measurements add up to 90, sorry. So if alpha plus beta equals 180 degrees. And I said it and wrote it wrong again. Complementary is 90, sorry. So 90 degrees. And then similarly, two angles are called, so let's give the names again, alpha and beta. Again, not necessarily in standard position. These are called, or are supplementary if their angle measurements add up to 180 degrees. Now notice here that although alpha and beta are the angles, I'm also just writing those names for their angle measurement, right? And this is something that I'm going to do a lot. So I'm not going to write, alpha degrees and beta degrees, even though alpha is the angle, that area between the two rays. I'm also going to use that symbol for the actual angle measurement. That's just one thing to note. So there's not much here, just something to know. I won't do any example because it's pretty straightforward. For example, an angle of 50 and an angle of 40, right? Those are complementary because they add up to 90 degrees, right? An angle of 110 and an angle of 70 are supplementary because they add up to 180 degrees. Right? So pretty straightforward. Now, we're going to be talking about degrees, minutes, and seconds. Right? So this is, again, something that you can attribute or think to the Babylonians. Babylonians like to work with a 60 base system. If you don't know what that is, don't worry too much about it. However, if you notice when we work with our numbers, we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 1, 1, 2, etc., or 11, 12, etc. That's because we work with a base 10 system. For a base 60 system, it's kind of similar, but a little bit more complicated in the sense that if you wanted to write, let's say, all of those first position numbers, so kind of like if you have, so again, for base 10, you can do something like 0, 1, 2, 3, 4, 5, etc., 9, then 1, 0. So if you want to write all of them out until you kind of need another digit, well, for base 60, you're going to have to do 0, 1, 2, 3, 4, 5, 6, etc. And depending on where you study this, they might use different letters or stuff like that. But essentially, you would have to count from 0 all the way to 59, right? And then all those numbers would be just the numbers in your base 60. Right? So really, it's very interesting. And if you ever take some sort of mathematical history class, you might study how different base systems work. They're very important. For example, our clocks or our time works in base 60. Right? We measure things in 60 seconds, 60 minutes, etc. Computer systems or computers in general just work in base 2 systems, right? The only digits are 0 and 1. That's base 2. Okay, and basically it all works like that. Computers are just a sequence of zeros and ones. Right? So working in different bases is very important. Right? But I just wanted to mention that a little bit just to explain why we're going to be working with minutes and seconds. Again, because it's just the base system that the Babylonians were using. Now, in most applications, we only work with degrees. However, there's a very, very common example where you actually see the usage of degrees and minutes and seconds. And that's if you're thinking about doing latitude and longitude measurements. Right? So you always hear things like the boat is located at a longitude of 40 degrees, 32 seconds, 32 minutes, 1 second, and a latitude of 90 degrees, 50 minutes, and 22 seconds, right? That's using the degree, minutes, and seconds measurement for angles. Okay? We'll talk more about, that sort of latitude and longitude measurements a little bit later. But for now, we just wanted to tell you that this does arise. Again, not so much. You're mostly just going to see degrees, but it does show up that sometimes you see minutes and seconds as well, including degrees. Okay? So suppose you have an angle measurement of 45.312 degrees. Instead of using decimals, we can use minutes and seconds. And this is another reason why you might want to use, in some cases, very rarely, but in some cases, minutes and seconds. It kind of simplifies your number so that there aren't any decimals. Okay? Now, in order to do this, we're going to need some unit conversions. So here are the units. 1 degree is equal to 60 minutes. Now, the symbol for minute is kind of like this apostrophe. So symbol for degrees, we saw, I think I've been writing it. I don't know if I mentioned that explicitly. So just in case I didn't, the symbol for degree is this symbol, like as an exponent, like a small circle. Right, so here, for example, I write 1 degree equals 60 minutes. And then if you reverse this, so divide both sides by 60, that is telling you that 1 minute, and again, remember that this apostrophe here is a symbol for minute, is equal to 1 over 60 degrees. Okay. So if we go from 1 degree to minutes, 1 degree is equal to 60 minutes. Now, similarly, 1 minute, and this we know obviously, 1 minute is equal to 60 seconds. And then the symbol we're going to use for seconds is 2 apostrophes in the exponent. So just dividing both sides by 60, that means that 1 minute is equal to 1 second. So this part here, let me underline it so you can follow. 1 second is equal to 1 over 60 minutes, which is equal to 1 over 3,600 degrees. So basically, these are the conversions that we're going to be working with. And again, the thing to remember is anytime you're using units of measurements, unless stated otherwise, it's important to make sure to include those units. So always include the degree symbol if you're using degrees, include the minute symbol if you're using minutes, and the second symbol if you're using seconds. That's basically all we need. Now we can go ahead and do some examples. So this is the example 1 from the packet. I would recommend that as I'm working through the lectures, and I should have said this at the start, but as I'm working through the lecture, make sure to have your packet with you because there's going to be space there for you to write notes down. There's going to be a lot of the formulas and definitions that I'm going to be writing are already going to be included in the packet. And the examples that I work here, the ones that are specifically from the packet, I'm going to label like this, like example 1 packet. And what you want to do is, ideally, you're going to work them with me as I work it here in the video. So again, the packet is a tool to improve your understanding and to aid you in this class. And it's worked very nice before with the previous coordinator. So he recommended that I use it here, and that's why I'm using it. Okay? But again, this is example 1 in the packet. So please work it as I work it with you here in the video. So convert the angle measurement 121.719 degrees into a measurement involving degrees, minutes, and seconds. Now, this video or this example is going to take a little bit, not too long, but it's going to take a little bit of work. So I'm actually going to stop the video here and do it in the next video.